The another most interesting topic is semiconductors. Semiconductor is a substance, usually a solid chemical element or compound, that can conduct electricity under some conditions, but not others, making it a good medium for the control of electrical current. Semiconductor materials can be divided into two general groups, intrinsic and extrinsic. An intrinsic semiconductor is chemically very pure and its conductivity is very poor. Some common intrinsic semiconductors are single crystal of silicon, germanium and gallium arsenide. These may be converted into the more powerful extrinsic semiconductor by adding some of the small amount of impurities. This process known as doping, which alters the electrical properties of semiconductor and improves its conductivity. For example, the atom of an intrinsic semiconductor such as elemental silicon has 4 electrons in the outermost cell. These electrons attach the silicon atom to its neighboring atom and so far are not free to move through the solid. Accordingly, since electric current rely on charge motion, pure silicon is poor conductor of electricity. If phosphorus atom with 5 outer electrons are substituted for some of the silicon atoms, the 5th electron is not needed for binding to adjacent atom and is free to move through the solid. Thus, doping silicon with phosphorus improves the silicon conductivity. Other atoms used for doping such as boron have 1 less outer electron than silicon. When they are submitted for some of the silicon atoms, each captures 1 electron from the neighboring silicon atom, leaving an empty space or a hole. Such holes behaves as they were freely moving particle with positively charged, and thus they are also served to increase the silicon conductivity again. An extrinsic semiconductor is commonly classified as N or P type depending on whether the impurity added has an excess of negative charge, that is N type, or a deficiency of negative charge, that is P. The P-type semiconductor can be defined as once the trivalent impurity atoms such as indium, gallium are added to an intrinsic semiconductor, and then it is known as P-type semiconductor. In this semiconductor, the majority charge carriers are holes, whereas minority charge carriers are electrons. The N-type semiconductor can be defined as once the pentavalent impurity atom such as Sb, arsenic, is added to intrinsic semiconductor, and then it is known as N-type semiconductor. In this semiconductor, the majority charge carriers are electrons, whereas minority charge carriers are holes.